We started off this chapter looking at cross-joins, which is a Cartesian product between two tables, where each row from one table gets joined with each row from the other table. And in the last video, we looked at inner joins, which are a cross-join with then an additional filtering step where we filter out rows that don't meet some specific join condition. In this video, we're going to be looking at outer joins. Outer joins add just one more step on top of inner joins. So an outer join consists of a cross join, and then there's the filtering step, but then a cross join will add missing rows back to the output. And which rows get added back to the output depend on what kind of outer join you're doing. There's three flavors of outer join. There's the left outer join, which will add rows back from what's called the left table. There's the right outer join, which will add rows back from the right table. And then there's the full outer join, which will add missing rows back from either the left or the right table. The best way to understand outer joins though is just to look at an example and get an intuitive sense of what's going on. I'll start us off with the query that we were using in previous videos, where we were performing an inner join between the film table and the film actor table. And what we noticed when we were doing this inner join was that there are certain films that don't have corresponding actors in the film actor table. And the net result of that was that those films don't appear in the output at all when you're doing an inner join. So if we run this query, and if we scroll down and have a look at the output, and I've ordered by the film ID here. So if we scroll down, there was a particular film that we were looking at, which had the ID of 803. And we can see that that's missing here again, because what we're doing at the moment is performing an inner join. We jumped straight from 802 to 804. If we did want that film in our output, what we could do now is use the left outer join. Let's go back up to our query. Let's change this inner join. Let's change it to a left outer join. And by the way, you can write left outer join, or you can just write left join. I tend to prefer just using left join or right join when I'm writing queries. The outer is implied. So if I change that inner join now to a left join and I run this query, let's have a look at our output. The output is the same for those rows where there was a match. But for those films where there was no match, where there are no actors for that film, what we now find is that they appear in the output now. So here's that missing film with the ID 803. What the left join effectively did is it still performed an inner join between the film and the film actor table. It filtered out all those rows where the join condition didn't match. But then what it did was add back in any missing rows from the film table. So any films that didn't appear in our output now get a row in the output. And one of those films is the film with the ID 803. So it now appears back in our output. It's as if we performed an inner join and then noticed that there were certain films in the film table that didn't make it, so it adds them back into our output. And when it adds it back to the output, what it does is it sets any of the columns that come from that film actor table to null. Because there is no corresponding film actor records matching for that particular film. It has no data that it could use, so it uses null. And this is why our actor ID here is null. The actor ID comes from the film actor table, and for this film with ID 803, there are no corresponding entries. So when it adds it back in, it sets to null any of the attributes or columns that comes from the table that was joined. This was a left outer join. And what the left means here is that it will add missing rows back from what's called the left table. Our left table here is the film table. You can think of your from clause as building up tables to join on from left to right. So we started with the film table, that's the left table, and then we joined the film actor table, that's the right table. And that's just because we're thinking in a left to right fashion. Film is on the left, film actor is on the right. And so when we say left join here, what that's specifying is to add missing rows back only from the left table, only from the film table. It won't add in any missing rows from the film actor table because that's the right table. If we wanted to only add rows back from the right table, what we would do is do a right join. In this case though, if you perform a join between the film and the film actor table, there will be no missing rows in our film actor table, and that's because of that foreign key relationship. There's no films that appear in the film actor table that don't appear in the film table. You won't see right joins used too often. If somebody wanted to do a right join, what they would often do is just flip the tables around. So you would swap your left and your right table, and then you would just rewrite this as a left join. So you don't tend to see right joins done too often. It's generally more intuitive for people to think left to right, so we tend to use left joins. There's a third type of outer join, which is called the full outer join, and a full outer join will add back in missing rows from both the left and right table, but I'll get to that in a second. So what are some of the applications of left joins? Well, if I asked you right now to write a query to return all those films that don't have any actors, we could use the left outer join to do that for us. What we've got right now is we're doing a left join between the film and the film actor table. And what we know is that when a film didn't have any corresponding actors, it still gets a row in the output, but the actor ID column will be null. And so we could simply search on that with a where clause. So we could say where the actor ID is null. And if we run that query now, we find that there are in fact 3 films, and one of those 3 is that film 803, Slacker Liaisons. So that's one application. We're able to quickly and easily find out which films don't have any actors. Another application of outer joins is you might be asked at some point to write a query which asks something like, how many actors are in each film? You might think, aha, well what I'll do is I'll just use an inner join and then I'll do group by and I'll use a count in my select clause. The problem though is when you perform that inner join between the film and the film actor table, you would be eliminating from the output any rows where there's no actors for a film. But what if you wanted that in your output? What if you wanted to say this particular film, 803, has 0 actors? If you're just using an inner join, those automatically get eliminated. So let's now actually write this query then. We want to find out how many actors are in each film, and we want to do that for all films, regardless of whether that film has 0 or more actors. So we've got from film, we left join on the film actor table and we join on the film ID. And then what we would have is a group by clause, because we're doing some aggregations, and we'll group by the film's ID, and I'll also group by the title as well. I'll maintain the order by clause, and so then I'll select the film ID, the film title, and now what I'll do is I'll return a count as number of actors. Let's run this query now and see if it does what we wanted. Let's scroll down through the output. Some of these values look okay. We could check them up and verify them if we wanted to, but I'm confident they're correct. Let's check though that film with the ID 803, because it should say 0. Let's see if we got that. It says there was 1 actor. That's interesting. What happened here? What you have to remember is that when you perform this left join, that film with ID 803 got added back to the output. It got a single row for itself in the output. If you now perform a group by and then you perform a count, when you use the expression count star, that returns the number of rows for that group. So for the group for film 803, count star is still 1. That's not really what we wanted though. We actually just wanted a count of the number of actors. What we can do to correct this is we can say count and we can say filmactor.actorID. If you recall from some of the earlier videos, when you say count expression, what that will do then is give you a count where that expression is non-null. And that's exactly what we need in this case, rather than just doing count star, because we don't just want to count the number of rows, we want to count the number of rows where the actor ID is not null. With this update, we can now run this query, and now that's correct. Slacker Liaisons shows as having 0 actors. This is a fairly tricky situation, by the way, so don't feel bad if this is a little bit confusing at first, and you need to spend some more time thinking about this and playing around with this demonstration on your own. A similar application that you'll often find for left joins, you commonly want a left join with some generated date table, which might consist of, for example, every day in some certain time interval. And that's because you may ultimately want to produce, for example, a chart where you maybe show the number of rentals each day. And you always want to include every day in your output, even those days where you had 0 rentals. You need that for your chart to be accurate and correct. And so you'll commonly find yourself left joining onto a generated table. With Postgres, you can use a really handy function called generateSeries that we've seen in some earlier exercises, and at the end of this chapter, you'll be doing an exercise like this. Okay, what I'm going to do now is jump back to that earlier query, because I just want to point out one more thing that you have to be careful about when you're doing outer joins, and you're dealing with this situation where you've got multi-joins in play as well. So I'll delete this code, I'll return us back to that original query, I'll run that so we're looking at the output. So this is just back to where we're inner joining the film table and the film actor table, and we're ordering the output. Imagine that you wanted to modify this query so that rather than just showing the actor IDs, you wanted to show the actor's full name, but with the additional modification that we also want to include films that have no actors. So rather than using an inner join, we'll change that to a left join. Okay, so let's set about now resolving that actor ID into the actor's actual name. To do that, we need to inner join onto the actor table. And what I can do now is come up here and add back in the actor's first name and the actor's last name. Let's run this query. That looks like it's worked, but let's have a look at that film with the ID 803. Because we used a left join up here, so we wanted it included in the output. Let's see what we got. It's missing. It's gone from the output again, even though we used a left join initially. And what happened here is that working left to right, we started with the film table, we left joined the film actor table onto it. So up until this point, everything's hunky-dory. We've got film with the ID 803 and it's in our output. But what happened then is that this table was inner joined with the actor table. And so that film, which had an ID of 803, had a null actor ID at this point. So when you try to join the actor table onto that with an inner join, then that whole row just gets filtered out again. We've essentially cancelled out the left join part of this, and it may as well have just been an inner join. Generally speaking, you have to be quite careful if you follow an outer join with any kind of inner join. There's a couple of different ways that you can get around this if you do want that film to still appear in the output. I find the easiest and most logical way is typically to control the grouping so that you effectively join the film table with a new table that is already an inner joined version of the film actor and actor tables. So what I want to do is still have the film table, and I want to left join onto that a new table, which is the film actor table, inner joined with the actor table, and the film actor table and actor table are inner joined with this condition. So I'll put that in parentheses. So now this is treated as one logical group. This is treated as one table where the film actor and the actor table have already been inner joined together. And then with the film table, I'll left join this new combined table on this condition. Let's run this query and let's have a look at the output. And I'll just put my ordering back in as well. Okay, if we have a look at the output now, we can see that we're still resolving for films that do have actors, the actual actor's name, so that part's still working. Now though, finally we've got what we want. We finally have this film with the ID 803 appearing in our output, and now for the actor ID, the first name and the last name, we've just got null, which is what you would expect, and it's what we wanted. So with the outer join, which consists of cross join, filtering, and then adding missing rows back in, we have the left, so we're adding missing rows back from the left, from the right, or we've got the full outer join, which is where we're adding rows back from both tables. The full outer join is not that commonly used. As I mentioned, what it will do is add back in any missing rows from both the left and the right table. One place where I've seen outer joins used to some good effect is when you want to visualize or aggregate and find out the degree to which different tables might have matching values. you might want to find out how much overlap is there between two tables. Let's imagine for a moment that we had a table which was the list of customers in the year 2012. Maybe it got imported from a text file or something like that. And then we have another table which is the list of customers in the year 2016. Again, maybe that got imported from a text file. You may at some point want to write a query where you find out how much has changed between the two tables. For example, you might want to know how many customers got deleted, so how many customers appear in the 2012 table but don't appear in the 2016 table, and how many new customers got added, so how many customers just appear in the 2016 table but don't appear in the 2012 table. What you could do is perform a full outer join on those two tables, and then using either a where condition or with case expressions in your select clause, you could do a count of how many customers only appear in the left table, so how many only appear in the 2012 table. You could do a count of how many appear in both tables, and you could do a count of how many appear only in the right table, so how many customers were only in the 2016 table, how many were new customers. And so a full outer join can be a useful tool to just look at the amount of overlap between two tables. So those are the three main joins: cross joins, inner joins, and outer joins. Get comfortable with these concepts because in the next video we're going to be looking at some advanced join topics.